You probably learned about pi in school. It was the number for circles. Someone told you the formula for the area of a circle was pi times the radius squared. Or the circumference was pi times the diameter. It seems simple enough, just another number to memorize for a test. Maybe you remembered it as 3.14, or if you were ambitious, 3.14159, and that was it. Pi was a tool for circle math. It belonged in geometry class, and that's where it stayed. But that's not the whole story, not even close. Pi is not just some number, it's a mystery. It's a thread that's woven into the fabric of the universe in ways that are genuinely strange. It shows up in places it has no business being. It behaves in ways that mathematicians have been trying to understand for thousands of years. The more we learn about pi, the weirder it gets. Its simplicity is a trick, a disguise. Behind that simple definition of a circle's ratio lies a depth that is, for all we know, infinite. So why is it so mysterious? The mystery starts with its digits. When you divide the circumference of any circle by its diameter, you get pi. It doesn't matter if the circle is the size of a coin or the size of a galaxy, the ratio is always the same. That's the definition. It's precise and unchanging, so you would expect the number itself to be simple. Maybe it's 3.14, and that's the end of it. But it's not. Maybe it's a nice fraction like 22/7. That's a good approximation, but it's not pi. It's just close. The truth is, you can't write pi as a fraction. Not ever. There are no two whole numbers you can divide to get pi perfectly. This means pi is what mathematicians call an irrational number. And that's where the trouble begins, because it can't be written as a simple fraction. Its decimal representation has to do something strange. It goes on forever, and it never repeats. Think about a number like 13. Its decimal is 0.33333. The 3's go on forever, but there's a pattern. It's predictable. You always know the next digit is going to be a 3, or a number like 17. Its decimal is 0.142857142857. It's a repeating block of 6 digits. After the 7, you know it's going to start over with a 1. There's a pattern, an order you can grasp. Pi has no pattern, at least none that anyone has ever found. The digits just keep coming. 3.141592653589793233846. They just keep going one after another with no apparent logic or rule connecting them. We have calculated pi to trillions of digits using supercomputers, trillions, and in all that time, in that endless string of numbers, no repeating pattern has ever emerged. And it just keeps on going, a chaotic stream of numbers spit out by a rule that is perfectly, pristinely ordered. This is the first great mystery of pi. How can something so simple to define the ratio of a circle's circumference to its diameter produce something so infinitely complex? It's a paradox. The rule is clean. The result is a mess. It's like having a very simple recipe that somehow produces a dish with every flavor imaginable, in a random order, forever. It shouldn't be possible, but it is. The quest to calculate these digits is a story in itself. For thousands of years, we've been chipping away at it. Ancient Babylonians used a value of about 3.125. The Egyptians used something around 3.16. The Bible, in a description of a round basin in King Solomon's temple, implies a value of 3. The first person to really attack the problem with pure logic was the Greek mathematician Archimedes. He didn't have a supercomputer. He had his mind and the sand of Syracuse to draw in. His method was beautiful. He knew he couldn't measure a curved line perfectly, so he faked it. He drew a circle, and then he drew a polygon inside it, with its corners just touching the circle. Then he drew another polygon outside it, with its sides just touching the circle. The perimeter of the inner polygon was a little smaller than the circle's circumference. The perimeter of the outer one was a little bigger. He knew the true circumference was trapped somewhere between those two values. And then he did the hard work. He started with hexagons with 6 sides, then he doubled them to 12-sided polygons, then 24, then 48, all the way up to 96-sided polygons. The more sides he used, the closer the polygons hugged the true shape of the circle, and the tighter the trap became for the value of pi. After all that work, he proved that pi was between 317 and 31071. It was the most accurate calculation of pi the world had ever seen. For centuries, mathematicians followed his lead, using polygons with more and more sides. It was grueling work. But then, in the 17th and 18th centuries, new kinds of math came along. Infinite series. These were ways of adding up an infinite number of smaller and smaller pieces to get a precise answer. Suddenly, mathematicians could calculate pi without drawing a single circle. They had formulas that would spit out the digits of pi. The more terms of the formula you calculated, the more digits you got. Today, we use supercomputers. The record for calculating pi is in the tens of trillions of digits. Why do we do it? It's no longer for any practical purpose. We don't need trillions of digits of pi to build a bridge or send a rocket to Mars. A few dozen digits are more than enough for any calculation in the known universe. We do it for the same reason people climb Mount Everest, because it's there. It's a challenge. Calculating pi has become a stress test for new computer hardware and new algorithms. And we do it out of pure raw curiosity. We keep looking at that endless string of digits, hoping that somewhere buried in the noise we'll find a message, a pattern, a secret. But we never do. And this leads to the second mystery, the mystery of randomness. The digits of pi appear to be random. They behave just like a sequence of numbers pulled out of a hat. If you look at the first 6 billion digits of pi, for instance, each number from 0 to 9 appears about 600 million times, just as you'd expect if it were truly random. This has led mathematicians to a fascinating question. Is pi a normal number? The word normal here has a very specific meaning. A number is normal if any sequence of digits you can think of appears in it, and appears as often as you'd expect by pure chance. If p is normal, it means that somewhere in its infinite string of digits, you will find everything. The string 0 appears, so does 123,456,789. Your birthday, written as a string of numbers, is in there. Your phone number is in there. The social security numbers of every person who has ever lived are in there. If you converted the entire text of Hamlet into a string of numbers, that string is somewhere in the digits of pi. The code for every computer program ever written is in there. The entire blueprint of your DNA, encoded as a number, is in there. Think about that. A number defined by a simple, perfect circle contains, somewhere in its endless tail, every piece of information that has ever existed, or could ever exist, as long as it can be represented by a finite string of digits. It's an idea so vast it's hard to wrap your head around. Pi could be the ultimate library, a library that contains every book, but also every book with one word changed, and every book that will ever be written in the future. It's a string of digits that seems chaotic and meaningless, but within it lies the code for all possible order. Now, here's the catch. We don't know if pi is normal, we think it is. All the evidence from calculating trillions of digits points to it. It certainly looks normal, but in mathematics, looking like something isn't enough. You have to prove it, and no one has ever been able to prove that pi is normal. It remains one of the great unsolved problems in mathematics. This is a deeper mystery than the first one. It's one thing for the digits to go on forever without a pattern. It's another thing for them to be so perfectly random that they contain everything. It makes you wonder what you're really looking at when you look at pi. Is it just a mathematical curiosity? Or is it something more fundamental? Is it a glimpse into the nature of randomness and order itself? The universe generated this number from a simple rule, and the number it generated looks like pure chaos, but a kind of chaos that contains all possible patterns. This would be mysterious enough if pi stayed where it belonged in the world of circles. But it doesn't. P wanders. It shows up in places that have nothing to do with circles. This is perhaps the most profound mystery of all. Why is this circle number everywhere? It starts in physics. Pi is all over the formulas that describe how our universe works. You see it in the equations for waves, like sound waves or light waves. The shape of a wave as it goes up and down can be described using functions called sine and cosine. And those functions are fundamentally derived from the geometry of a circle. Imagine a point moving around a circle. If you track its height over time, it draws a perfect wave. So anything that vibrates or oscillates has a hidden connection to circles. And where there are circles, there is pi. It gets deeper. Pi shows up in quantum mechanics and Heisenberg's uncertainty principle. This is the rule that says you can't know both the exact position and the exact momentum of a particle at the same time. The more you know about one, the less you know about the other. The formula that defines this fundamental limit on our knowledge of the universe has pi in it. Why? Because at its heart, quantum mechanics is a theory of waves. Particles are also waves. And so the number for circles is baked into the very foundation of reality at the subatomic level. And pi is also in Albert Einstein's equations for general relativity. These are the equations that describe gravity as the curvature of space-time. They tell us how planets and stars bend the fabric of reality around them. And right there, in the heart of these massive universe-defining equations, is that little number from your middle school geometry class. pi. It's there because these equations deal with the geometry of a four-dimensional universe. And pi is the ultimate constant of geometry. When you talk about spheres and volumes and curvature, even in dimensions you can't see, pi is there. So pi is not just the number for circles, it's the number for waves, the number for quantum uncertainty, the number for gravity. It seems to be a fundamental constant of the universe itself, and it doesn't stop with physics. PIA shows up in probability theory in the mathematics of chance. There is a famous problem called Buffon's needle. Imagine you have a wooden floor with parallel lines drawn on it, all spaced an equal distance apart. Now, you take a needle that is exactly as long as the distance between the lines. You throw the needle onto the floor randomly. What is the probability that the needle will land crossing one of the lines? The answer is 2p. This is shocking. It makes no sense. There are no circles anywhere in this problem. There are only straight lines and a straight needle, so where on earth does pi come from? It comes from the randomness. The needle can land in any position, but it can also land at any angle. The total range of possible angles is 360 degrees, or a full circle. When you average out all the possibilities of position and angle, the geometry of the circle, the geometry of rotation sneaks in. And it brings p with it. People have actually performed this experiment throwing needles or toothpicks thousands of times. And the results they get produce an approximation of pi. You can calculate pi by throwing sticks on the floor. If that's not mysterious, what is? Pi even shows up in the normal distribution, the famous bell curve. The bell curve describes the distribution of all sorts of things in the real world, the heights of people in a population, scores on a test, the measurement errors in an experiment. The formula for this essential ubiquitous curve has pi in it. Again, no circles in sight. But the mathematics behind it, which involves calculating the area under the curve, relies on concepts that are deeply related to the geometry of circles in higher dimensions. It seems pi is a fundamental number not just for space, but also for probability. It governs not just the shape of the world, but the shape of chance. The mystery continues in the natural world. Look at a river. Rivers tend to bend and meander as they flow across a plain. If you measure the actual length of a river from its source to its mouth and then divide that by the straight line distance between those 2 points, you get a number called the sinuosity ratio. It's a measure of how bendy the river is. In 1996, a scientist named Hans Henrik Stolum demonstrated that the average sinuosity of rivers all around the world is, you guessed it, approximately pi. This is almost unbelievable. Why would the bending of rivers have anything to do with the ratio of a circle's circumference to its diameter? The explanation is complex, a mix of fluid dynamics and chaos theory. As a river bends, the curve becomes more and more pronounced until it loops back on itself, creating an oxbow lake and a new, straighter path. Over time, the river is constantly making loops and cutting them off. The balance between these two competing tendencies, a kind of geometric tug-of-war, averages out to p. The river is, in a statistical sense, trying to form circles and then destroying them. So p is in the heavens, in the orbits of planets, and the equations of gravity. It's in the subatomic world, in the uncertainty of quantum particles. It's in the abstract world of probability, in the tossing of a needle, and it's here on Earth in the very shape of the rivers that carve our planet. This ubiquity is a core part of its mystery. Pi is a number that seems to connect everything. It's like a secret signature left by the universe in all these different domains. It tells us the things that look completely different on the surface as well. A circle, a wave, a bell curve, a river edge are all connected by a deeper mathematical reality. And pi is the number that represents that connection. This leads to the final mystery, which is a more human one. The mystery of our own obsession. Why do we care so much about this number? Why have people dedicated their lives to calculating its digits? Why do we celebrate Pi Day on March 14th? Why do people compete to see who can memorize the most digits of pi? The world record is over 70,000 digits. It's an incredible feat of memory, but it's also, in a practical sense, completely useless. We are obsessed with pi because it represents a certain kind of perfection and a certain kind of infinity. It represents the tension between the simple and the complex, between order and chaos. The definition of pi is perfectly ordered. It is a single, unambiguous, unchanging value. It is pure, but its expression, its decimal representation is chaos. It's a wild, untamable, infinite jungle of digits. We are drawn to this. It's a reflection of our own experience. We live in a universe governed by simple physical laws, yet the world we experience is chaotic, complex, and unpredictable. Pi is a mathematical metaphor for that experience. The quest to calculate Pi is also a story about human limits. For centuries, we tried to pin it down, to find the end of it, to find the pattern. We thought if we just calculated a few more digits, we'd solve it. We now know that we never will. We can never see all of pi. It is an infinite mountain that we can continue to climb, but we will never reach the summit. And there's something beautiful and humbling in that. It represents the endless frontier of knowledge. There will always be more to discover. Memorizing pi is another strange part of this obsession. It's a mental Everest, but it's also a way of internalizing this mystery. To hold tens of thousands of those random digits in your head is to carry a piece of that ordered chaos within you. It's a form of devotion to an idea. So what is the ultimate answer? Why is pi so mysterious? The mystery is not that we don't know what pi is. We know exactly what it is. It's the ratio of a circle's circumference to its diameter. The mystery is everything that follows from that simple fact. It's mysterious because it's infinite, but comes from a finite shape. It's mysterious because it's ordered in its definition, but appears chaotic in its digits. It's mysterious because it might contain every possible string of numbers, making it a library of everything. It's mysterious because it belongs to the circle, but it appears everywhere, in every corner of science and nature. Pi is a number that feels like it shouldn't exist. It's a bridge between the perfect geometric world of ideas and the messy, complex real world. It connects the purely abstract to the physically tangible. It is a constant reminder that the simplest things can be the most profound, and that if you look closely enough at something you think you understand, you might find a mystery that goes on forever. In the end, maybe we're not meant to fully solve pi. Maybe its purpose isn't to be an answer, but to be a permanent question. A question that has pushed us to invent new kinds of mathematics, build faster computers, and think more deeply about the nature of reality. Pi is a number that reflects the universe back at us, ordered and chaotic, simple and infinitely complex, known and fundamentally mysterious. And it all starts with a simple, perfect circle.